Alright guys, in this video we're going to start working on the area of complex or combined shapes. Essentially over the last week we've gone through the area of a square, we've gone through the area of a parallelogram, area of a triangle, followed by the area of a trapezoid. The different formulas are up at the top. Something you may want to start doing is just have your study note beside you. Start making it now and just have an example of, I guess, what we call going forwards, finding the area, subbing in the variables properly, getting your answer, and working backwards, finding either the length or the width, i.e. one of the dimensions that we use to find the area. Obviously, it's more complicated with the trapezoid because we have three different choices for working backwards. A and B are similar. H is a little different, and that's one of the things you did yesterday. All right, or at least have done in this unit. So today we're going to work on the area of combined or complex shapes, and the trick when you're doing these types of ideas or these types of shapes is look for smaller shapes you recognize hidden within the larger area or larger shape. Now in this case it's a little easy. Let's just label these up. 10 centimeters, I don't know, 15 centimeters, 5 cm. We'll go with 9 cm, I guess, based on that. And based on all these dimensions, we can now figure out the area of this more combined or complex shape. They're all going to be these simple shapes up top combined together in some way, shape, or form. Given the dimensions here, the first thing I do is I look for the two shapes that I can label it up as. And I've actually got two choices in this case. I can cut this up into a rectangle and a triangle, or I can cut it up into a trapezoid and a rectangle here. I like using triangles because they're a little easier than using the trapezoid formula, so I'm going to cut this up into two shapes. First thing I do is I label up shapes. I give them a name, so I'm going to call that shape 1, I'm going to call that shape 2. Shape 1's a triangle, shape 2's a rectangle. Now, triangle here is missing some of its dimensions. We need to know the length of this dashed line. I know that if I look at this side here, it's 15 centimeters going across. Up top takes up 9 of those 15. That means that this here is 6 centimeters long. On the other side, I know the distance here, is 10 centimeters. The other side, here to here, is 5. And the triangle itself goes from where the 5 ends all the way to the end of the 10. That means that this here is 5 centimeters and that this here is 5 centimeters. So now I've got all the dimensions I need to solve this problem. So something that we are going to have that is new in this unit is what we call the the area total, or AT. AT is equal to A1, the area of this small triangle, plus the area of the rectangle. So these little subscripts here, subscript means below the script line. There's some old school English for you. Tell us what area we're finding with each shape. So I'm going to find A1. A1's a triangle, so I use its triangle formula. Base times height divided by 2. This is the version I like to use. And then I start putting in the variables I know. I know the base is 6 centimeters. I know the height is 5 centimeters. Stub in and solve, and it's that easy. These are both line lengths. When line lengths are multiplied together, they make an area. Remember your unit math. So 30 centimeters squared, we divide by 2. The area of the first shape is equal to 15 centimeters squared. We find out the area of the second shape. The area of the second shape is a nice easy formula. It's just base times height. It's a rectangle. I'm running out of room here. I really shouldn't have started here. B is equal to 15 centimeters. And the height is equal to 5 cm. Kind of sloppy math in this case. 15 centimeters times 5 cm is equal to 75 centimeters squared. The area total is equal to these two added together. So I don't have to rewrite what area 1 and area 2 are or what they represent. I can actually just sub the numbers in because they're defined here. So area 1, as long as I put everything in the right order, is 15 centimeters squared plus 75 cm squared equals 90 centimeters squared. Leave yourself a little more room than I did on examples or questions like this. I'm going to do one more in another video, just an example of a combined shape that doesn't add, but has a hole in it. So in other words, it takes area away from the original shape. And that'll be in the next video.